Hi everyone, my name is Alex Hodges and welcome to the first of 5 lessons designed to introduce you to the field of wireless networks and mobile computing. In this first lesson, we will explore wireless networks and common protocols used with them. The importance of wireless networks has never been greater than it has in modern history. In fact, according to market research conducted by PR Newswire, the revenue in the global wireless market is expected to expand from $1,431.3 billion in 2019 to $5,519.4 billion by 2024. With the recent pandemic, the position of wireless networks and wireless internet access as an important staple in homes and the workplace has never been more proven and solidified. As more and more wireless devices become available, wireless networks are becoming more prevalent and, in some cases, even preferred. Imagine, for example, if all the computing devices you have around you had to be connected to share data. That means anything that communicates to other devices. How inconvenient would it be if your phone had to be connected to your smartwatch, headphones, laptop, and another person's phone to send data to all those devices? You would have to constantly move cables and reconfigure devices just to send that meme to your friends, and you still wouldn't even have internet access until you plugged into the wired IT infrastructure. With the importance of wireless networks growing, it's even more important that we have a workforce that has at least a basic understanding of these networks, their offerings, and their drawbacks. So without further ado, welcome to the wonderful world of wireless. In this first lesson, we will explore wireless networks and their common uses, types, and protocols. By the end of this lesson, you should be able to define a wireless network and its benefits, compare and contrast a wireless and wired network to identify advantages and disadvantages of each, as well as determine when each should be used, identify types of wireless networks, their benefits, drawbacks, and differences, and identify when they are used, choose a simple model that is most appropriate for a given straightforward scenario, and finally, be able to match simple, common wireless protocols and standards to their uses. In this section of the lesson, we will explore the basics of what defines and comprises a wireless network, as well as a brief history of wireless. So to understand wireless networks and protocols, we must first establish what a wireless network is. Put simply, a wireless network is a communications network where data can be transmitted and connections made without cables. In a wireless network, communication takes place using radio waves, much like how walkie-talkies or your car radio would work. The history of wireless networks is a long, somewhat complicated one. However, most agree that one of the most important developments on the road to wireless networks was the invention of the wireless telegraph in 1896. This telegraph, developed in the UK by Guglielmo Marconi, operated in a similar fashion to the regular telegram, in that the information was transferred via Morse code by pulses of radio waves of 2 different lengths called dots and dashes. The transmission is then received as audio, which is translated. For the first half of the 20th century, telegraph remained the prominent wireless communication technology. This was until the first generation of mobile phones hit the market. The mobile telephone service by AT&T became the first generation of mobile telephones in 1946, often referred to as the start of the 0G generation. The system used radio waves to link the mobile phones to the public switch telephone network. In this service, the caller wasn't calling an end user directly, but rather wirelessly calling the operator, who connected them with the receiver via the PSTN, which required a hard connection. In this service, the caller had to search for an open channel before calling, and the call would be a simplex connection, meaning only one person could talk at a time. AT&T would later improve on this system in a number of ways, most notably by making the service duplex in 1964. These phones were large and typically only installed in cars or other locations that were unable to have a wired connection. However, the next event would lead to an era of shrinkage in technology. The invention of the transistor in 1947 by three American physicists, John Bardeen, Walter H. Brattain, and William B. Shockley at AT&T Bell, was revolutionary as a viable alternative and eventual replacement to the electron tube. Due to the transistor's small size, low heat, low power consumption, and high reliability, circuitry began the process of miniaturization, a process which continues to this day. It serves as an amplifier, controller, and/or generator of electrical signals in circuits. In 1962, AT&T Bell, which later became Nokia Bell, launched Telstar 1, making it the first orbital communications satellite. This satellite facilitated the transmission of live TV and phone signals across the globe, with its primary task being to receive signals from the US, amplify them 10 billion times, and return them to Europe, and vice versa. In 1968, the development of ARPANET was in full swing, which became the precursor to today's modern Internet. This network was a military research project to connect computers over long distances without the need for cables. The system used existing phone lines to connect to other computers around the world and was one of the first to use the TCP/IP model, while also standardizing several other protocols like FTP, Telnet, email, and more. AlohaNet was a network system developed in 1971 at the University of Hawaii to connect computer systems across islands. It was the first to demonstrate wireless data packet transfers utilizing an experimental UHF, or ultra-high frequency. It was one of, if not the first, network to utilize packets in the Aloha protocol, still used today to establish an initial link, a random access protocol, a shared medium access, and more. It also helped lead directly to the development of Ethernet and personal wireless communication technologies. In Japan, in 1979, the beginning of cellular networks occurred, often referred to as 1G. Unlike the MTS and IMTS, the call was switched automatically and could be transferred using various cellular sites rather than just one radio mast. In 1986, wireless networks were brought to the masses with the WaveLAN products developed by NCR. Its proprietary protocols laid the basis for Wi-Fi and other wireless standards. From these points, Wi-Fi and wireless networks have continued to evolve. We are now on 5G cellular networks and Wi-Fi 6, and other wireless technologies, like Bluetooth and Zigbee, have grown in popularity quickly. Uses of wireless networks. In theory, wireless networks can be used anywhere that wired networks are used. In modern technologies, they often have similar, if not identical, speeds and security. However, wireless networks are best used in places where mobility is preferred or even required, or where running cable may be dangerous, costly, or just impossible. Wireless is used in nearly every location we visit today, but a few common examples of where they can be seen are cafes, hotels, offices, homes, libraries, and anywhere that is a hotspot utilizes wireless. Much of the hardware used in wired networks are also used in wireless networks. Obviously, you need routers, switches, and devices. However, these devices are slightly different for wireless networks. Wireless networks require a wireless-capable router that broadcasts the radio signals for devices to connect to. For a device to connect to these routers, they need a wireless adapter of some kind, which often is a wireless network interface card, or NIC. With just these two pieces of hardware, a simple wireless network can be made. However, it is highly likely that more will be needed. In order to access the internet, for example, there must be at least one wired connection from the wireless router to the modem or internet access medium. If there is a LAN backbone or system that a client would like to connect to wirelessly, then a connection is required to this as well. It is highly likely that your wireless router will not give you the range required to reach all of your wireless devices. In this case, using access points, extenders, or switches to extend the range and amplify the signal may be necessary. As with any network, security is also needed. Therefore, many networks, both wired and wireless, include a hardware-based firewall as well. Wireless networks may seem complicated, but at the surface level, they communicate in a relatively simple way. Say a client wants to connect to the internet wirelessly. In this case, the wireless adapter, like a wireless NIC, will send radio waves out into the air. From here, the waves are received on the wireless router, which passes the data via wired connection to the LAN or out to the internet. The requested data or connection is then sent back the same way. At each machine, the radio waves are converted into machine-readable binary. Along the way, the signal may come into contact with other devices. A wireless access point is a common type of device that is used in creating a wireless network. They amplify and extend the signal from a wireless router by being directly connected via a cable to the router. On the other hand, wireless extenders amplify the signal by intercepting the signal wirelessly from the router or access point and then rebroadcasting the signal to cover a larger area. The following picture shows a brief description of how wireless networks work. If the laptop wants to send a message to the internet, which will then go to the desktop, it will send data in the form of a radio wave to the wireless router, which will then pass that radio wave data to the modem, then to the internet. Then the message will come back the way it came and be sent from the wireless router to the desktop. How do I connect? Connecting to a wireless network is simple. All that is needed is an area with a wireless connection or signal, also known as a hotspot, and an adapter of some sort that can pick up and translate the signal into a usable format for the machine. Once connected, some further steps may be required, such as inputting a password, authentication, and more. In the following slides, we will go over some review questions. Question 1. How do wireless networks communicate? Answer B. Though the data is converted to an electrical signal, it transmits as radio waves. Review question 2. Name one place where a wireless network may be used and why it may be used there. Answers will vary. For an example, wireless networks are commonly used in public places where quick, easy access is needed without having to run loose cables. Question 3. A device or computer must have some form of wireless adapter to connect to wireless networks. Answer A. True. All wireless devices have some form of wireless adapter aboard. Section 1 Review Answers. Question 1. How do wireless networks communicate? B. Radio waves. Question 2. Name one place where a wireless network may be used and why it may be used there. Answers will vary, but could include libraries, offices, homes, and so on. Reasons could include cost, ease of use, mobility, and so on. Question 3. A device or computer must have some form of wireless adapter to connect to wireless networks. True. Now that we know a little bit about wireless networks, let's compare them to wired networks. When comparing wireless and wired networks, there are several advantages that each may provide in a given scenario. These advantages play an important role in determining what network type is chosen in each location. Wireless network advantages include installation speed and simplicity, cost, increased mobility and flexibility, wider access, many connections, no wires, scalability, bring your own device, convenience, and ease of use. The biggest advantage in a wireless network is increased mobility. Users can move around without having to worry about carrying around a cable and reconnecting every time they need to access the network or internet. Within the area covered by the network, users can move to any location and work from any device, allowing for flexibility and increased productivity. One of the other huge benefits of wireless networks is the ability to increase range of access. Wireless allows for connectivity in locations that may be difficult or even impossible to run cables through. Obviously, wireless networks also end up being neater and more organized. This is largely due to the fact that there are no cables to deal with or organize, and having less cables makes the infrastructure more easily traceable when physical work on the systems is needed. The fact of having no cables also makes the setup easier and quicker, and sometimes even cheaper when compared to a wired network. Running cables can quickly add up. A foot of Cat5e will set you back about 25 cents, while the same distance of Cat8 Ethernet will be nearly 3 times that amount at 70 cents per foot. Likewise, the scalability of wireless networks also benefits from this lack of cables. To add a new device, no new cables have to be run. Instead, it just needs to be in range of the wireless network. This is also possible because of the number of users that wireless networks can handle. While too many users will still make the network performance suffer, a wireless network is not limited to the number of ports available on a switch or router. Wireless technologies also increase the use and success of BYOD policies, which can further cut down on costs. Finally, wireless is simply convenient and easy to use for both employees and customers. Being able to transport a device wherever you may go and connect to get some work done benefits both the individual and the organization from both directions. Customers often appreciate a guest network that they can connect to easily, which allows them to utilize their devices on the go, while employees are free to work from any location at any time. Wireless also makes some processes much easier, such as file transfers from devices to other devices, especially from a device like a phone or tablet. Advantages of wired. While wireless networks have numerous benefits, wired networks have their advantages and place as well. Wired networks provide more control over their connected devices and their security. In the same light, it is typically more difficult for an attacker to gain access to a wired network. Though wireless can be nearly equivalent to wired speeds today, wired networks perform better overall. This is because, since they do not use radio waves, they tend to have less interference, instability, and complications. Advantages play just as big of a role as advantages when choosing a type of network. Therefore, understanding both is crucial to making a well-informed decision. Though there are many benefits to wireless networks, they tend to suffer more severely from interference, instability, and degraded signal strength and quality. This is largely due to the distance the signal has to travel, the number of devices connected, and what the signal has to pass through. Wireless networks tend to have an increased security risk as well, as it is typically easier to get into a wireless network. Once in, a wireless network has less control over its connected devices. Therefore, a device could be carrying malicious packets or using outdated protocols or security measures. Speeds on wireless, though relatively similar to wired speeds, do tend to be slower overall. Additionally, while a wireless network tends to be cheaper in most cases, it can end up being expensive or extremely difficult to manage. Wired networks also have several disadvantages. First, and most obviously, the cables they require can be expensive, messy, and hazardous. Wired networks also tend to be more complicated to troubleshoot, as a particular cable or device likely needs to be physically located before it can be fixed or certainly replaced, and is less likely to be resolved remotely or via software. Expanding a wired network is usually much more time-consuming and expensive than expanding a wireless network. A new device must be ordered, shipped, installed, configured, cabled, and so on. They are also much less convenient and mobile, requiring a cabled connection to a station at all times. Additionally, the number of users a wired network can support is limited to the number of ports a device, be it a router, switch, or otherwise, has. Question 1. Name 2 advantages and disadvantages of a wireless network. Answers will vary. Advantages may include mobility, convenience, BYOD, cost, and so on. Disadvantages may include interference, speed, security, and so on. Question 2. Name 2 advantages and disadvantages of a wired network. Answers will vary. Advantages may include better speed and security, and so on. Disadvantages may include messy/hazardous cables, inconvenience, cost, and so on. Section 2 Review Answers. Name 2 advantages and disadvantages of a wireless network. Answers may vary, but advantages may include mobility, convenience, bring your own device, cost, etc. Disadvantages may include interference, speed, security, etc. Name 2 advantages and disadvantages of a wired network. Advantages may include better speed and security, etc. And disadvantages may include messy or hazardous cables, inconvenience, cost, etc. Now that we have learned about the advantages a wireless network can bring, how do we know what kind of wireless networks an organization, home, or individual may need to suit their needs? Well, first, it is important that we familiarize ourselves with some of the most common types of wireless networks. Today we will explore 5 of the most common. Wireless Personal Area Networks, WPANs, are networks with a very small range of about 30 feet. They are used to connect small, personal devices around a central location and typically use Bluetooth or other such protocols. These networks typically connect things like smartwatches, headphones, and speakers to mobile phones. These networks typically have moderate performance and use standards such as Bluetooth, IEEE 802.15, and IRDA, Infrared Data Association. One of the most common wireless networks we see are Wireless Local Area Networks, or WLANs. Much like wired LANs, these networks cover a limited local exposure area and are commonly used in areas such as a university campus or library. They are also commonly used as an expansion of a wired network or another wireless network. WLANs typically have high performance and use the IEEE 802.11, Wi-Fi, and HyperLAN standards. Wireless Metropolitan Area Networks, or WMANs, are networks located within a city and usually span roughly 30 miles. They are typically seen in urban settings. They typically connect multiple networks from several buildings in the area, including offices, schools, and public services, and serve as both an alternative and a backup to copper and fiber networks. WMANs typically have high performance and utilize either the Wi-Fi or the IEEE 802.16 and WiMAX standards. The proprietary protocols and standards may be used. Wireless Wide Area Networks, or WWANs, are large-distance networks that can spread over cities or countries and typically rely on satellites and/or antennas and work closely with ISPs to ensure connectivity. They typically work to connect smaller networks like WLANs and WMANs together. These networks typically have low performance and may utilize several standards, which used to include CDPD, or the Cellular Digital Packet Data, but is now predominantly cellular networks from 2G to 5G. Ad hoc networks are a form of WLANs, but they have some unique characteristics. Specifically, ad hoc networks are formed primarily on an as-needed basis, especially when other connections and/or Wi-Fi are not available. Instead of utilizing a central base like a router or switch, these devices are free to forward traffic amongst themselves. These networks are commonly seen in disaster relief efforts as quick, simple solutions to get connections and communications running. A hybrid network is a network that incorporates components of several network types and technologies. For example, it may include both wired and wireless components. Since their inception, wireless networks have proven to be severe security threats, and this is only truer today as the occurrence of attacks increases and their tools become more and more available. Therefore, it is important to know the most common security solutions for wireless networks and their strength. The first security solution for wireless networks that was widely implemented and standardized was the Wireless Equivalent Privacy, or WEP solution. In the early days of wireless, the providers wanted to make its setup and use as easy as possible, so the security was left to a minimum. When WEP came around, it proved not to be much better. WEP was released in 1999 and was designed to provide the same security level as a wired network. It used a static key consisting of a 40-bit key with a 24-bit initialization vector. This IV is an arbitrary number that, when used with the key, encrypts and decrypts data. However, the IV was sent in clear text. Additionally, WEP used the reversed cipher 4 algorithm for encryption, which is a stream cipher dependent on a stream of data and is one of the most widely used stream ciphers because of its speed and simplicity. Since WEP could be broken so easily, due in large part to the clear text IV, the key was extended to 104 bits, though this did little to fix the issue. This solution is now considered obsolete and highly vulnerable, as well as difficult to configure. WPA was designed as a temporary replacement for WEP that followed the 802.1x standard to be used along with other enhancements until the next standard could be established. 802.1x EAP was the Layer 2 protocol that enabled a wireless client to authenticate to a wireless network and was used heavily in WPA and beyond. The solution operates in two modes, personal and enterprise. Personal mode was designed for small office, home office uses and works by creating a pre-shared key for authentication. This key must be configured on each client and access point, but no authentication server is needed. It also used TKIP for encryption. TKIP was very similar to RC4, but was much longer. However, it also generated different keys and base keys each time. Enterprise mode was designed for large companies using an authentication server to centralize authentication keys or certificates. While WPA was far better than WEP, it was still very vulnerable and somewhat difficult to implement. WPA2, the most common solution today, is a vast improvement over the other two. This solution, also known as 802.11i, uses the Advanced Encryption Standard algorithm, which is approved for top-secret information by the U.S. government. It features a symmetric key, symmetric block cipher, and keys from 128 to 256 bits. Though not perfect, especially if using the Wi-Fi protected setup, it is very highly secure and is considered the best standard as of now, as well as the easiest to configure. Question 1. WEP is more secure than WPA. False. WEP is far less secure than WPA and should never be used. Match the wireless network type to its description. WLAN is a range of one building, uses Wi-Fi. WMAN is a range of a city or region, uses WiMAX. WWAN is a range across cities and beyond, it uses cellular. And WPAN is a range of about 30 feet and primarily uses Bluetooth. Section 3 Review Answers. WEP is more secure than WPA. False. Match the wireless network type to its description. A. WLAN goes with D, range of one building, uses Wi-Fi. B. WMAN goes with A, range of a city or region, uses WiMAX. C. WWAN goes with B, range across cities and beyond, uses cellular. And finally D. WPAN goes with C, a range of about 30 feet, and uses Bluetooth. Finally, as you move into the IT field, it will be important to know that network protocols are out there and what standards should be met. However, this gets very complicated very quickly, so we will just be going over the surface level of some of the most common. Common wireless network protocols. The most common wireless protocol, regardless of wireless network type, is Wi-Fi. Wi-Fi is typically used in WLANs, but can be used in most of the other types as well. Wi-Fi is a category of protocols and covers any protocol that uses the 802.11 family of IEEE specifications. Similarly, WiMAX is used primarily in WMANs and is a category of protocols that use the 802.16 family of IEEE specifications. Another common wireless connection type is cellular networks. These networks are used most frequently on cell phones, but can also be used on tablets and other mobile devices. They are also the primary method of data transmission for WWANs. WPAN protocols are abundant, but the most common is Bluetooth. However, plenty of others exist, such as Zigbee, IRDA, RFID, IEEE 802.15, and many more. The use of these protocols can likely be recognized when connecting wireless devices like headphones to your smartphone. Cellular networks and WPAN protocols will be discussed in more detail in later lessons centered on mobile devices and computing. There are many IEEE specifications. The 802.11 family is huge. Therefore, we will only cover some of the more common standards. First, the IEEE 802.11 standards are a family of specifications developed for WLANs and other wireless networks. They are considered industry standards and are widely used across the world. The original 802.11 standard is now obsolete, though it was considered the original Wi-Fi standard. It supported up to 2 megabits per second and a 2.4 gigahertz frequency range. Typically, later letters are newer. They also provide increased throughput, speed, and so on. The most common of these standards is 802.11b. This standard applies to any protocol that operates within the 2.4 gigahertz range, which is an unregulated and very overpopulated range with devices of all sorts. This can create significant interference in a network. However, devices using this protocol are generally inexpensive. It has a maximum speed of 11 megabits per second. The 802.11g protocol improves on 802.11b by increasing the maximum speeds to 54 megabits per second, though it still uses the 2.4 gigahertz channel. The two protocols are compatible, but mixing the two is not recommended. 802.11a is a protocol which introduces a new frequency range, the 5 GHz range. This leads to much less interference and competition, though the maximum speeds are still at 54 megabits per second. Hardware using this protocol is generally more expensive. IEEE also has a category that houses standards that are in development but are not yet approved by IEEE. These protocols are typically labeled with the 802.x label. Apart from the IEEE standards and their evolution, the actual Wi-Fi protocol and label has applied to specific standards and evolved along with the IEEE standards, often selecting the best current option to receive the next version label. This numbering and standardization was introduced in 2018 and was retroactive. Thus, instead of having to identify a specific IEEE standard, administrators or devices could simply refer to the Wi-Fi number. Wi-Fi 1 was assigned to the first release standard, 802.11. This standard supported speeds up to 2 megabits per second and used the 2.4 GHz frequency range. This standard introduced 3 physical layer technologies to reduce interference: direct sequence spread spectrum, frequency hopping spread spectrum, and diffuse infrared. These technologies were crucial to the success of Wi-Fi. However, exploring these concepts in detail is beyond the scope of this lesson. For more information and resources regarding these technologies and others discussed, please see the instructor. This standard is the backbone of Wi-Fi, which all other later versions are built from. Wi-Fi 2, established in 1999, was assigned to IEEE standard 802.11b. This version was nearly identical to Wi-Fi 1 in all ways except speed. For this Wi-Fi version, the speed reached rates up to 11 megabits per second. Wi-Fi 3, also established in 1999, was assigned to 802.11a and increased speed up to 54 megabits per second. It also introduced a new 5 GHz frequency range that reduces interference, as there are far less devices on this band. However, the 5 GHz band also, in theory, reduces range. This is because this band tends to be more absorbed by building materials than the 2.4 GHz band, likely due to the difference in wavelength. This is one place that physics can be applied to the IT field. More information and resources on radio waves and the physics of IT can be received from the instructor. Wi-Fi 3 also introduced orthogonal frequency division multiplexing, which allows many signals to be transported over one medium simultaneously. Wi-Fi 3E is often described as an expansion of Wi-Fi 2 and was assigned to 802.11g. This Wi-Fi version increased speed in the 2.4 GHz band to 54 megabits per second. It also encouraged and sped up the development of backwards compatibility between the Wi-Fi versions. Since many devices were, and still do, use 802.11b, there was immense concern that devices running on Wi-Fi 2 would not work with the new Wi-Fi 3E. This encouraged the development of backwards compatibility between the two and explains why Wi-Fi devices commonly advertise their supported versions as 802.11b/g. Wi-Fi 4, established in 2008, was assigned to 802.11n, which builds on to the 802.11a standard. Wi-Fi 4 allows for speeds up to 600 megabits per second and uses both 2.4 GHz and 5 GHz frequencies, allowing for more connected devices with less interferences, as well as providing more options dependent on the needs of a user, be it speed or range. This Wi-Fi version also introduced support for multiple input, multiple output antennas, which allow multiple antennas to be used in communication with mobile devices and multiple devices. Put simply, it allows for multiple paths to increase the network capacity. More information on the MIMO antennas can be found in the resources provided to the instructor. Wi-Fi 5, established in 2014, was assigned to 802.11ac and builds on the 802.11n standard. This standard increases speed to a maximum of 6,933 megabits per second and operates on the 5 GHz frequency band. When used in conjunction with Wi-Fi 4, it allows for 802.11n standards on the 2.4 GHz range and 802.11ac standards on the 5 GHz, as they are very similar. The most recent Wi-Fi versions, Wi-Fi 6 and 6E, are not yet widely available. These versions, which build on the 802.11ac standard, provide speeds up to 9,608 megabits per second and use 2.4, 5, and 6 GHz frequency ranges. Review questions. Number 1. Which of the following is a wireless network standard? Answer D. All of these are wireless standards, though some may be outdated or obsolete. So now let's review a few key points from each section. Section 1. As you can recall, wireless networks have no cables and use radio waves to communicate. Additionally, a wireless network must have a wireless capable router and devices to have a wireless adapter to connect. In Section 2, we learned of several advantages and disadvantages for both wireless and wired networks. Here we learned that while wireless networks are more flexible, mobile, and scalable than wired networks, and are typically cheaper, they are also harder to control and more susceptible to threats, interference, and degraded performance. In Section 3, we explored the wireless network types and their purposes. Clearly, WLAN is the most common, but the rest are also heavily prevalent. We also learned about the various encryption and security methods and established that WPA2 was the most secure and should be used. Finally, in Section 4, we learned briefly about the various wireless protocols. The most common ones, Wi-Fi and 802.11, are the key takeaways here. Wi-Fi is a set of IEEE WLAN protocols that follow the 802.11 specifications, and the 802.11 specifications set forth in IEEE are home to numerous wireless protocols. Next, we will conclude with a brief final assessment. So let's check your knowledge. This brief assessment will reinforce what you learned from this lesson and identify areas that may be worth looking back over. Question 1. A wireless network is a network that communicates using satellites. Answer: false. While a wireless network can use satellites, it does not have to. Question 2. Based on the following scenario, should this organization use a wired or a wireless network? A group wants to have easy access speeds and reliable internet, but demands that employees be mobile. They also have numerous areas where cables cannot be run. Answer: because they need mobile access and have some places where cable cannot be run, wireless is ideal. Question 3. Which wireless network type would you recommend for connecting offices on opposite sides of the country? Answer: WWAN. Since the network is connecting offices across the country, far beyond city limits, a WWAN is the best of these choices. Question 4. Which protocol introduced the 5 GHz frequency range and operates at a maximum of 54 megabits per second? Answer: A. While 802.11g also operated at 54 megabits per second, the 5 GHz frequency was introduced with 802.11a. Final assessment answers. A wireless network is a network that communicates using satellites. False. Should this organization use a wired or wireless network? A group wants to have easy, convenient access with fast speeds and reliable internet, but demands that employees be mobile. They also have numerous areas where cables cannot be run. Because they need mobile access and have some places where cable cannot be run, wireless is ideal. Number 3. Which wireless network type would you recommend for connecting offices on opposite sides of the country? WWAN. Number 4. Which protocol introduced the 5 GHz frequency range and operates at a maximum of 54 megabits per second? 802.11a. This concludes Lesson 1. For more information on this and other related topics, check the references at the end of this presentation or discuss with the instructor. You may now move on to the hands-on activities for this lesson.